Okay, so this projectile sheet, let's get into this real quick. Okay, to solve projectile problems, you must divide up your information in two parts. You must divide it up into the horizontal and the vertical, which has uniform motion. You guys might not have got that. And the vertical that has accelerated motion. Because remember, okay, in the x direction, speed is constant. So there is really no initial velocity. It's all velocity because it's constant or uniform. You could say constant or uniform. It doesn't matter. And then the vertical is accelerated because of gravity. So this is what I did this time. Same equations. That's a bad F, but same equations. Instead of the A's, I put G, 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 because we're dealing with gravity, acceleration due to gravity. Okay, and so this dy here. So let's take a look at what we got here. First of all, let's do our x and y tables. Okay. Okay, so I've put my table. I've listed my givens in the x direction. I've been given 3 meters. I don't have velocity in the x direction. I'm going to write this down always. I've got my distance in the y direction. I've my acceleration due to gravity. Remember, it's an a or a g. And then I have initial velocity in the y direction. So the first thing I'm going to do, I'm going to solve for how long was the ball in the air. So it's asking for time. So I'm going to look over here and say, okay, can I solve what I got in the x direction time? I've got dx, yes, but I don't have vx. I don't have the initial velocity in the x direction. So I can't solve it using an equation, this equation. So I've got to use one of these equations now. Okay, so what equation can I use if I'm looking for time? So I'm going up here looking for time. Let's see, do I have final velocity, initial velocity? Don't have final velocity, so I'm not going to use that. So final velocity, not going to use that. Okay, so again, I'm going to use my third equation here. So for A, it's dy. I'm going to plug all this in. The dy is 1 meter. Initial velocity is 0. So I'm going to do away with this part of the equation, right? So I'm going to do away with that. And now I have half of gravity, which is 9.8 meters per second squared, times time squared. Okay. So now we know that's 4.9. So we have 1 meter equals 4.9 times time squared. So we're going to divide 4.9 on both sides. Divide 4.9 on both sides. And 1 divided by 4.9, I don't really remember what that is. 1 divided by 4.9 equals 0.2. So I've got 0.2 equals time squared. So I've got to take the square root to get rid of this thing here. So now I have the square root of 0.2. Let's see what the square root of 0.2 is. So the time of flight is 0.45 seconds. Now let's look at B. All right, so let's look at B. It says with what horizontal velocity did the ball roll off the table? So we're looking for horizontal velocity. Okay, we're solving for horizontal velocity. Do we have what we need to solve for that? Okay, all we need is this equation because we have the dx, and now we have the time because we just solved for the time. So now horizontal velocity, we're going to say is, let's just write the equation, vx equals dx over t. So now we have the dx is 3 meters over 45.45 seconds. Let's say meters over 45 seconds. So the velocity in the x direction is, okay, so it's 6.67 meters per second. That's our velocity in the x direction. Okay, now let's look at C. All right. Okay, so now let's look at C. It says, what is the vertical velocity of the ball just before it hits the floor? Okay, so we're looking at the final velocity is what we're looking for. So final velocity, initial velocity, x direction is gravity times time squared. I think we will use. We've got this. We've got final velocity equals initial velocity. We have that, and we got gravity, and we got distance in the y direction. So we'll use this one. I said we'd use this one. Maybe this will be easier. So we'll just use that. I think it'll solve the same for the same thing. So let's just use that. Let's use final velocity equals initial velocity was, we're talking about in the y direction. It's 0. Okay, and then we have gravity and we have time. So all we have to do is initial velocity is 0 meters per second plus 9.8 meters per second squared times time. We found that at 0.45 seconds. Okay, so now we just got to go 9.8 times 0.45. Okay, and our answer is, it's asking for vertical velocity of the ball just before it hits the floor. So our final velocity is 4.4 meters per second. But we could have used this equation; it would have given us the same thing. So anyway, I think that was an easier equation. So we just use that one. All right, what is the horizontal velocity of the ball just before it hits the floor? Okay, the horizontal velocity, that's pretty easy because it's in uniform motion. So the horizontal velocity, d, it's in uniform motion. So the whole path of this projectile, this projectile that's launched off the cliff or whatever it was, in the x direction is the same velocity the whole time. So we solved for velocity already. So velocity in the x direction is uniform. So same as, I guess, answer B. How's that? Okay, so that's all we're going to do on this page. So we'll pause there. Okay, so this page is talking about projectile motion. The one factor that the horizontal and vertical components of projectile have in common, they have time in common. Okay, and the ball's in the hand of the quarterback who is in the process of throwing it. The ball's motion is accelerated. He's in the process of throwing it. As soon as he lets it go, though, after he releases it, it's uniform in the horizontal direction. Okay, it cannot accelerate anymore. It's released from his hand. It's uniform in the x direction. Okay, in the vertical direction, vertical motion, it's going to accelerate due to gravity. Okay, so the problem, the ball is pushed horizontally off a table that is 6.1 meters high. The ball has a velocity of 11 meters per second. When it leaves the table, how far away from the table does it hit? Okay, this is just another horizontal motion and vertical motion, projectile motion problem. All right, so same thing. Break it up into vertical and horizontal components, and by the problem, just identify the variables And then for this one, it was a little different because it says the ball is pushed off a horizontal table at 6.1 meters high. The ball has a velocity of 11 meters per second. When it left the table, how far away from it, the table does it hit? Okay, so first of all, step one, you got to solve for time. Okay, so I solved for time using one of our equations, our kinematic equation. So when I solved for time, I was able to go back and plug it into this formula. Remember this velocity in the x direction equals distance in the x direction over time. So I plugged it into that formula, basically. I didn't write that down in the column, but I wrote it down here. So solve for dx, and if you have time, solve for dx. There you go. That's it. Okay. Okay, weight is a force, so it would have to increase until it equaled the weight of the object. When this happens, the net external force acting on the object equals zero. Okay, so it stops accelerating, and the object no longer accelerates. Okay, and it's reached terminal velocity. All right, and then the motion will be uniform. It's not going to accelerate anymore. Once it's reached terminal velocity, it's not accelerating. So I only have about 45 seconds left on this video, so just put the answers in here for you. Check it out. An object weighing 10 newtons is in free fall. The net force acting on the object is 10 newtons, right? The object accelerates at 9.8 meters per second. When the object encounters 4 newtons of air resistance, the net force will be 6 newtons. Now the object accelerates. Acceleration will be less than equal to 9.8 meters per second. All right, read the rest of that, see if you can make sense of it. And here's the next page. Okay, that's the last thing you're going to need here. I mean, there was a bottom part of this page, but we didn't really go over it. So anyway, use this to study by, and if you got any questions, let me know. I'm posting this right now as we speak. I'm getting off, making the post. See ya.